Okay, I just wanted to post another video about my WWVB receiver decoder. So starting off, we've got the receiver decoder module, or receiver module here. This particular one is sold by a company called Universal Solder. And it outputs into these two transistors, which form a Darlington pair. And then this Darlington pair actually drives another transistor, which drives this LED, this green LED, and this shows the actual pulse modulation from WWVB. A pulse of 200 milliseconds is a 0, 500 milliseconds is a 1, and 800 milliseconds is a marker bit. And then this Darlington pair also drives this transistor here, which drives the trigger of this 555 timer through this capacitor, because we just need a pulse. We don't want a constant low trigger input, because that will mess with the timing. So the output of this 555 timer goes high for roughly 350 milliseconds. At the expiration of that 350 milliseconds, it goes low again, which actually goes through an inverter formed by this, actually, let's see here. It's formed by this NOR gate, which then feeds the input of these two chips together, form a single bit register, also known as a D flip-flop. Actually, here's a schematic here, and I screwed it up, but this actually is down here. But the clock goes in here. The digital input actually goes in here without this acting as an inverter. The inverter's down here, and here the signal is inverted. And this acts as the D flip-flop. So this outputs a 1 or a 0, and also if it's sensing a marker bit, that is also outputted as a 1. So there's no differentiation between a 1 and a marker bit. So the output of this register is output to this LED, and I should say it's output to one side of the LED, and the other side of the LED is driven by, again, the output of this 555 timer, and together it'll cause the LED to flash red with a 0 or blue with a 1 or a marker bit. So I'm working on improving this circuit, and the next version, I'm going to be pretty much ripping out all of this. Next version will have inverters, hex inverter, 556, because I'll actually need 2 timers. And instead of 2 ICs forming a single bit flip-flop, I'm going to have a dual D flip-flop IC, so 2 registers in 1 IC. And then I'll have a 7-segment display, which will actually display a 1 or a 0, and then flash a dash for a marker bit. So that's the plan, and I'll see you back when that happens. Thanks for watching. Bye-bye.